Today I'll talk about the microservice. It's been here like in the last 5 years. It's been like trending topics for the in the IT space. So I'll talk like when you could build a microservice architecture for the application. So when you could think about monolithic or modular, right? So when you basically building a MVP or initial stage or prototype, the monolithic is a good option to go for. The moment it's gain a traction and we are building this product and probably you could split this monolithic to kind of modular architecture. So the moment you see that you're getting more traction, sufficient traction to test the microservice complex architecture, or do you have to scale this product, or you have to accommodate more transactions, or you want to decouple the basically all the requests, right? So in that case, probably you could go for a microservice architecture. It doesn't require at the initial stage, to hop into the microservice architecture, because even though you create it, you don't have enough requests to test them. So test them, probably you have to look for a third-party software or the libraries where exactly inject or the simulate all this, high number of requests. But it is again, it's not required why to spend a lot of money on the resource hiring to go for a lot of, a very complex process. So when you're designing a microservice, what are the things you have to consider? You have to look into flexibility, maintainability, fault-tolerant, and scalability. Definitely scalability. That is the key, right? So exactly flexibility, what you could do it, right? So you should make each thing like very much modular, and everything can be, scale or update independently. There should not be any dependencies between two or multiple services, right? Maintainability, if you talk about, you make a smaller, well-defined service which is very much simplified one. So it will be very easy for the debugging, testing, and for the iterative development, right? Team can take it up into the next level. If you make a very complex service, still bring the dependency into the service, then it's very hard for developer to, develop in fast pace, test them, deploy on that, because there is dependencies, right? So whole idea to come into the microservice to take off your dependencies from each service and give the independent responsibility to the particular service, right? And you have to think about the fault tolerance, right? So let's say if one microservice goes down, it should not bring down the whole application. So if one service goes down, still the application should work. There should not be any issue. So how you can handle this? There is a scalability. Yeah, definitely you should be able to scale your product or the service very much. If you cannot scale, yes, let's say according to load, according to your requirement, utilization or reducing the cost, you cannot optimize your service, then it's a very difficult position. So you should think about all this perspective or the point you have to consider to bring the scalability into the particular microservice. So then now talk about how the microservice exactly communicate. What is the right approach for it? So there are if you talk about the approach, mostly I'll talk about three approach. One is direct communication, which is called synchronous. It's one service wants call to the other service. So the other service has to respond immediately with a response. If you make a delay or its response time is high, then there is an issue. And then you have to look a lot of stops into this. The second service goes down. What happens to the first service? You have to look for a kind of retry mechanism and so on. But again, if you go to the retry mechanism, then it's consume a lot of things, memories, the other resources, it goes off. So this implementation has to be very careful, and synchronous communication is kind of direct approach. Yeah. So then it is called asynchronous communications, where the two service, they don't communicate each other directly. There is a third party or third end of message broker. Via message broker they do communicate. So if service one want to send a request to the service two, so basically service one comes with the request, dump into this message broker, she'll publish this to the message broker, and then wish to consume this message, right? And again, the message to, if you need to pass something, the service 2 will dump the response for this service one, and service one will consume from the broker. This is how it should work exactly in the asynchronous mode. But in the most of the application, they do use the hybrid one. Like, some percentage on the synchronous mode and some percentage on the asynchronous mode. People talk about the aggregations business, like, and there is a couple more like Unicommerce, retail tech aggregator. So this kind of application mostly, ideally it should use 60 to 70% asynchronous, 30% synchronous process should execute to bring the more accuracy. Right? So all this, those things not really need to deal with the real time, the asynchronous process. And you want to show something to the customer. It's more interactive with the customer that has, probably you have to go for a real time system. In the recent era, you could see a lot of delivery apps or B2C, D2C apps. So those application has a kind of service called notifications. So this notification have to solve very quickly. So for that, you have to go for some complex architecture. So on that sense, you cannot handle with the synchronous process. That has to go through the asynchronous, and you have to add some component which is very high throughputs, and probably you could look for a distributed architecture. And that's how it works exactly. Yep. So how this direct communication works, like basically you could use HTTP, HTTPS or gRPC or maybe GraphQL API calls for this. Yeah. Otherwise, basically this is HTTP calls, so you have to make it, right?